She's been living in the shutdown with her cute little dog, which hopefully she'll show you. But anyway, I'm going to turn it over to Stella, and we will take questions at the end, please. So if you'll all keep yourself on mute, and if you have questions, I think you can write them in the chat. Is that right, Stephen?
Yeah, please put them in the chat, and if you could just turn off your microphones just to cut down on background noise, it helps.
Okay,
so, yeah.
Great. Stella, it's all yours. Thank you.
Thank you. So thank you so much for joining me today. I've always been saying that social distancing should not be social isolation. So as soon as doors open, I'm pretty sure we're all going to go back to our clubs and to our regular social life, but it's great to be able to connect this way. So thank you again for joining us tonight. I am going to start sharing my screen right now. Click. And I'm going to turn off my camera because I tend to distract people. So as Jill mentioned, today I'm going to talk about Betelgeuse. I'm going to tell you a very interesting story that stirred up a lot of discussion around this really very bright star, and it's still part of the headlights. But before I do that, I want to start with acknowledgements. As Jill mentioned, this is Ruru. This is my research assistant. This is my little COVID puppy. Now he's 9.5 months old and actually enjoying the snow in Massachusetts. That's his favorite hobby. And that's what he does for a living, being cute. But also he has been keeping me sane for about a year now. So I'm very grateful to him for actually keeping me sane. So with that, let me start by reminding you that the AAVSO is an international association formed in 1911 to connect professional and amateur astronomers for scientific projects. We were formed in order to do citizen science. This is our mission. The mission is to enable anyone, anywhere to participate in scientific discovery through variable star astronomy. And what that translates to is an international community of individuals with very, very diverse astronomy interests. Our community consists of people with different needs, different priorities, different habits and cultural background, people who have been with us for years and those who have just joined us and are collectively interested in helping understand some of the most dynamic phenomena in our universe, which are variable stars. Just to remind you, variable stars are stars whose brightness is changing with time, within timescales that we can measure here on Earth, with respect to other stars that do not change with time. So what I mean by that is that we can actually measure those brightness variations, and those brightness variations have nothing to do with the Earth's atmosphere, has nothing to do with turbulence, has nothing to do with clouds or weather. They are intrinsic to those stars. They have to do with stellar properties. And actually, we can measure those brightness variations using all types of means that we have available, like telescopes or DSLR cameras, or even visually through our binoculars. And here's actually one of my favorite examples demonstrating variable stars. This is a star cluster. This is M3. And this particular movie was generated by a series of 3 consecutive digital images that were taken the same night back to back, and they were converted to a movie. Now, each dot that you see here represents a star, and most of them are actually stars in the cluster. You can see bright stars, you can see faint stars, right? Now, if you keep a closer look, you'll see that most of the stars don't do anything. They just stay there, even though we are actually moving from image to image to image. However, some of those stars are actually changing their brightness, like this one, or this one, or this one. Or we can actually play a game. How many variable stars can you count? These are the type of variable stars we're interested in studying at the AAVSO. And the way that we study them is by measuring their brightness change with time. So our tool here, our tool is a plot of this brightness change with time. And as the brightness is changing, we are recording those changes in different points. And this is what we call a light curve. This is our main tool for photometry. Keep that in mind. We're going to talk about light curves a lot. Now, as a game, if we were to take a measurement of the brightness of a non-variable star, a constant star, In principle, it should be just a straight line because it's not changing, right? With that, let's move to Betelgeuse, the star of today's discussion. This star belongs in the constellation of Orion here, which is part of the Northern Hemisphere winter triangle, quote unquote. So we have Orion. Oof, where's my truck? Back here. Orion, Canis Major, and Canis Minor and Canis Major. This is the winter triangle. Now, according to the Greek mythology, Orion is a giant, like a hunter, and he has two dogs, right? The big dog and the small dog, Canis Major and Canis Minor. And Betelgeuse is on the shoulder here, or armpit, of the giant, and pretty much he's followed by his two dogs. So if I go back, this is Betelgeuse, and these are the two dogs of this of the giant. So going back to the star itself, this is a beautiful picture of Orion. It's actually, you should be able to see it now from where you are. Betelgeuse is a really bright star. It's the 6th or 7th brightest star in the night sky. It is an evolved star. It's past its adulthood, so it's what we call a supergiant. It's about 700 light years away, which means that light emitted now from the star will take 700 Earth years to travel to Earth. Its mass now is 12 solar masses. It's also quite a large star. Its radius, it's about 880 times the radius of the sun. So in this diagram, this is actually a real image of Betelgeuse. This is the size of the Earth's orbit around the sun. If you put the sun in the center, this is the size of Jupiter's orbit. And this is the size of Betelgeuse. So imagine a star with a radius as large as the distance between the sun and orbit, or even larger than that. Now, it is a variable star. And as a variable star is what we call a semi-regular variable star. So what does that mean? This is the long-term light curve of Betelgeuse. More than 100 years of data that we have. The earliest points actually are around the late 1800s. And this is actually showing that Betelgeuse is variable. So it's changing with time. It's not a straight line. As I mentioned, this is a semi-regular variable, which is actually an evolved star, a giant or supergiant in general, that is showing some periodic changes in the brightness that is accompanied or sometimes interrupted by all kinds of irregularities. So looking at this light curve, we can see that there are changes in the brightness. We knew that the star had ups and downs, so that's something that we definitely knew. But a century of variation shows that the brightness of the star is confined between these two lines, more or less. The open circles are visual data, so a little bit less accurate than digital data. These are data that were acquired by people actually not even looking through binoculars. I mean, Betelgeuse is really very, very bright. But if you notice some green points here, these are V magnitude data. These are filtered data taken with digital means. So why are we even discussing Betelgeuse right now? I mean, you see the variation, we knew it for 120 years, et cetera, et cetera. Well, check this out. In October of 2019, the star began dimming and dimming and dimming until it became the 21st brightest star by December 2019. Now, from the 7th brightest to the 21st, people noticed. There was something that it never did before. It was really bizarre. It was fainter than some of the stars in the constellation of Orion. From the brightest star in the constellation, it became much fainter than Rigel itself. And here's actually the light curve again. I'm focusing here only on the V magnitude stars, showing the similar effect. These are the limits where Betelgeuse's brightness is moving or was moving for 120 years. And here we are in 2019. So actually, what's interesting is that we had real pictures that is depicting that. This is a picture of Orion, the hunter, the whole constellation in 2019. And here it is a year later. So if I just go back and forth, you can see how faint Betelgeuse is, right? So people really noticed. They saw it, they observed it, they took pictures of it, trying to figure out what on earth is going on in there. And the way of figuring it out was to go back and review what we know about this star. So as I mentioned, Betelgeuse is a giant star. We know that giants are aging stars, stars that expand because they have exhausted their fuel in the core. So our sun will become a red giant 4 or 5 billion years from now. Now, Betelgeuse started its life as a 15 to 30 solar mass star somewhere here. And then after it moved from its main sequence, so it evolved, it got rid most of its outer layers, and it ended up as a star with the mass that we see today, which is about 12 solar masses. Also, now we know a couple of things about this particular phase, the supergiant phase in a star. This is a phase which star loses so much mass that all that remains are the leftover cores, right? So that is where the difference in mass comes in. Supergiant phase. We also know that supergiants are extremely bright during this time. They are releasing copious amount of light in the form of photons that zoom outwards in all directions. This light is pushing considerable mass outwards in the form of grains or dust. We don't understand how it happens, but we know that stars like Betelgeuse have such irregular dust emission episodes. Now, dust acts like a blanket, and as it cools and dissipates, dust grains will absorb some of the light heading towards us and block our view, resulting to a partial dimming of the star. Actually, for Betelgeuse specifically, we know that it does show dust episodes. This is an image of Betelgeuse that was taken by ESA's Herschel Space Telescope. And this is an infrared, at infrared wavelengths, that is actually much more sensitive in detecting gas. And what you see here, dust. And what you see here are shells of material, asymmetric shells of material, that actually it's ejected by the star and is clumping and actually becoming dust. So we know that Betelgeuse has dust episodes, right? So that's one of the things that we know. We also know that Betelgeuse atmosphere is highly convective. This is definitely not unusual, as convection is pretty much ubiquitous in stars. So, for example, we know that the sun has a lot of convection. And actually, we know from the sun lots of properties of convection. If we dissect the sun, this is a core, and this is the outer layers, then there is an outer layer of the sun that has a lot of where convection happens. So in this case, what we have is heated material moves towards the surface, it cools down and sticks at the bottom of the layer when it's heated again. Actually, it looks more like a boiling water in a pot. All the bubbles that come out are a result of convection in water. Water is rising up and it cools off and then it goes all the way down. That's how I explain convection actually to my nephew who's 10 years old. And he absolutely loves this analogy. Now, something like that happens in the convection zone of the sun, right? Another simulation here that showcases how it is. And you know, here's a really fun picture, a movie from a new telescope, here, Earth telescope, during its commissioning. And you can see how convection looks like a boiling soup. What I love about the sun is that it's very nearby. So we have the privilege and the opportunity to take high resolution images like this. This is a real movie from the sun. Now, we also know that red supergiants do have convective cells like that. This is a simulation. It's not a real picture, but it's a simulation showcasing convective patterns on Betelgeuse's atmosphere that occur in 2 different timescales. And actually, this is reflected on the light curve of Betelgeuse. The first one is a long-term one. So you can sort of see it here. You have to trust me, I guess. It's more of a sinusoid, semi-periodic, that lasts for about 5.9 years. The second one is much more short-term. It's these wiggles that it shows. By the way, this is where Betelgeuse is behind the sun, and we can't observe it. So these more or less last for about 425 days. And both patterns are due to convection. So we have a lot of history about Betelgeuse. That's all we know. What is the reason for the dimming? This dimming is much, much, much deeper than before. Can we use this past knowledge to explain the dimming? So the running theory was that the current dimming is due to an extreme, there we go, extreme 425-day dimming cycle within the big 5.9-year one. So you have 2 of the cycles of the star overlapping at the same time. So once the brightness was going low, it just pushed the system lower. It created a huge dark spot as a result of convection that covered a lot of the light of the star. So that is what caused this unusual dimming. And the good thing is that when you make a theory in astronomy, you should be making a prediction. Actually, when it comes to observational astronomy, this prediction can't be tested. So in this particular case, the prediction is that the atmospheric temperature of Betelgeuse should be lower at minimum, as the star's outer atmosphere will be dominated by the cooler dark spots, and that the brightness of the star will recover by the beginning of April of 2020. So we are in January here, right? There's another theory, actually, a competing theory that said, well, what if we have another asymmetric dust episode? You know, we know that Betelgeuse does that. In this particular case, we have to be a very, very extreme dust episode. And it is consistent with what we know about stars like this one, and actually specifically this one, but still dust. These two comes with a prediction. What happens then is that we will see dust around the star at the time of dimming, and the star brightness will recover when the dust dissolves. So we had to wait and see what happens, right? And the system did recover in April of 2020, which actually, in a really funny way, it proves both theories. So that this was one of the predictions for both. Actually, people started believing theory number 1. So you have 2 overlapping periodicities, 2 overlapping spot cycles that coincided at the same time. So you have huge dark spots on Betelgeuse, but at the same time, we needed more. There were more data that were taken. This is an infrared image that was taken in December of 2019. Actually, there you go, with a very large telescope in Chile that shows dust surrounding Betelgeuse, and actually a very dense episode of dust emission. In this photo here, the very, very center, this little orange dot is Betelgeuse. The dark disk is actually blocking most of the light of the star so that we can actually see the dust around it. So what people said is that, you know, dust may explain why the star recently dimmed. And at the same time, a new study by Levesque and Massey 2020 revealed that there was no significant temperature change in the atmosphere of this star at between minimum and maximum. So dark, cool spots, not so much. However, what actually gave the most likely explanation was the very persistent work of a group from CFA led by Andrea Dupree that actually use the Hubble Space Telescope to observe Betelgeuse at different phases. This is an artist's conception, right? It's not a real picture. I wish we could actually go there. But this schematic summarizes several months of Hubble's UV light spectroscopic observation of Betelgeuse, beginning in January of 2019. And it actually shows a timeline. More or less, it tells a story of what happened with the darkening. So pretty much what we have is that a southern region here of Betelgeuse is evolving, and it gets a bright hot blob of plasma, and actually this particular blob of plasma is ejected from the star towards the Earth from the southern direction. Now that it cools at some point and it forms an enormous cloud of dust that obscuring the light from Betelgeuse. So this particular panel reveals the huge dust cloud blocking the light as seen from the Earth from a quarter of a star's surface. This actually provides a solid story. What this particular story says is that material is leaving the star's visible surface. It moves out through the atmosphere before the dust forms, and then dust forms and causes the star to appear dimmer. So what we think right now is that an extensive dust episode is the primary cause of this dip. That does not exactly excludes the overlapping dark spots, but it explains, it's very consistent as a timeline with the data, with the information that we have seen so far. The cool thing is that this particular story has attracted a lot of attention. So if you want to read more about Betelgeuse, there's a great article coming up in Sky and Telescope, the March issue, that tells you more, gives you more information you would like to read. So I really encourage you to take a look at this one. Now, where are we right now? This is a very, very, very recent picture of Betelgeuse. The star's brightness recovered. This is what is happening this year. So it actually started showing that it was going dim. It didn't go as dim, it recovered, and so on and so forth. Bottom line, we need to keep observing it. Now, I gave a lot of presentations on Betelgeuse. As you can imagine, it was a very, very exciting phenomena to study. It was really fun. And the most common question that I'm getting is, well, will it become supernova? That was not an unreasonable assumption, by the way, because our current understanding of supergiants is that they're going to evolve at some point and become supernovae, right? Now, in the case of Betelgeuse, this event is predicted to happen anytime within the next 200,000 or 300,000 years. In principle, though, no one knows what the star does right before it becomes supernova because that particular phase has never been observed. So although this will become supernova eventually, this dimming of Betelgeuse is not connected with the supernova phase. So what we see now is not necessarily a precursor of a supernova. Now, another question that I get very often is what will happen to the post-supernova phase? So there's a possibility of a neutron star, a black hole, right? So actually, the answer is that we don't really know. If the remains are less than 2 to 3 solar masses in the central region, then Betelgeuse will become a neutron star and will have a beautiful pulsar very close to Earth. So it's going to be quite spectacular even then. If the explosion remains are more than 3 solar masses in the central region, then it will self-gravitate, it will implode, it will create a black hole. So lots of uncertainty, but lots of theory. So stick around for 300 more years to see actually what happens with Betelgeuse. What I absolutely love, though, is that this discussion triggered the imagination of people who made assumptions on how Betelgeuse will look like as a supernova in our night sky. So this is Betelgeuse as it looks like right now. And this is an artist's rendering of how it will look like if it goes supernova. So Betelgeuse is going to be brighter than the moon, so bright that we will definitely be able to see it. For those of us who love observations, it's going to be a very bright source of light pollution. So let's hope it will not get supernova. Well, I'm not really sure, actually. I should be very careful what I'm wishing for. Maybe I want it to go supernova, but fade really fast. Just stay there for a couple of days, which is not going to happen. Here's another artist rendering of Betelgeuse right next to a full moon. So it's going to be much, much brighter. It's going to be really spectacular. So what next? What happens next? We need more data. It's really cool that one of the brightest stars in the night sky turned out to be one of the most interesting ones. And what I find even more interesting is that only small telescopes can monitor its behavior. All the data enabling this research were acquired by small telescopes. Small telescopes, binoculars, photoelectric photometers, DSLR cameras, because actually Betelgeuse is too bright for big telescopes. They saturate, right? There's no detector that can actually observe it in a 16-inch telescope, like a CCD camera, for example. It's going to saturate for a star as bright as this. But actually, we're able to identify this peculiar behavior of Betelgeuse because of the hard work and dedication of hundreds of AAVSO observers who acquired data on this star for more than a century. So now we have a picture. So what happens then? We need your help. This is an advertisement for you to actually start, join the campaign and keep observing Betelgeuse. You never know what's going to happen next year. If you have access to a telescope, even a pair of binoculars, you can actually take measurements. Or if you have a DSLR camera, you can definitely contribute to this research. And we're here to tell you how. We have what we call a 10-star tutorial that you can definitely download for free from the AAVSO's webpage. And it actually tells you exactly how to take measurements of Betelgeuse. I would actually see it as a challenge for you. I would like to leave you with this particular challenge to try and make your visual observations of Betelgeuse. It's going to be extremely rewarding. Trust me on that. Also, I want to plug in a couple of other things that are happening at the AAVSO. We are running a webinar series around all kinds of subject matters. This year, we are this webinar series are scientific presentations, mostly by professional astronomers who have used AAVSO data, and they are presenting and discussing their own results. Some of these presentations have to do with our observing sections, so they are telling more or less, they're discussing how they are doing observation of specific objects. They're all free, so I would like to encourage you to participate. It's actually every second, 2 Saturdays a month. And also we have what we call how-to hours. This is exactly what it sounds. We are discussing specific aspects, practical aspects of variable star astronomy, and they're free as well every first Saturday of a month. So please go to our webpage and take a look and register. It's going to be a really nice company for you if you want to learn something about astronomy and see how contributions of small telescopes are making huge difference when it comes to astrophysical discovery. Also, we started a collaboration with Ball State University and the International Planetarium Society with the goal of bringing more astronomy into everybody's home and guide individuals to make a first scientific observation, just their first scientific observation. Pretty much every month, we're bringing a constellation into your home and a variable star of interest in this constellation with information how to take a look at it and even try your own observations. It's a really fun project, especially if you have little ones around you or individuals who just want to enjoy learning something about a constellation in the night sky. It comes with videos and it comes with a brochure you can actually download. And this month, February, it's Betelgeuse. It's highlighting Betelgeuse. Everything is free. It's open source. Please go to our web pages and download all the material. And I can actually send you links if you're interested in a little bit later. So some last thoughts. you know, in the limited time that we've had, I hope I managed to convince you to try your hand in variable star astronomy and join us in our quest to explore and understand the universe. Even the brightest stars in our night sky, stars that we have been observing for more than 100 years and we think we know their behavior, can really surprise us. Variable star astronomy is really exciting because we just don't know what happens next. Like reading a mystery and unveiling different parts of that mystery every single day. These are actually exciting times. Betelgeuse is only one example of the cool science that small telescopes, a well-curated database, and a lot of patience can actually achieve, and a collaboration amongst people. So right now, the 21st century is a renaissance of variable star astronomy. There's so many space and Earth missions that aim at exploring the night sky, and they will produce just mysteries. They're not going to solve them. And there are not enough professional telescopes to acquire the data needed and the help that we need in order to solve these mysteries. So at this point, the AAVSO is an essential resource for researchers all over the world. If not anything else, we need more observers. So I'm trying to recruit all of you to take observations and join the AAVSO. Because really, only with the help of people like you, we can understand some of the fantastic phenomena in the universe. So I'm going to leave you with our information. The AAVSO will be by your side along the way when you start your quest. This is our webpage. You can find all the information about the resources we have, the information we have, anything that you need there. This is an email that you can send us, you can contact us with questions. There's no such thing as a simple question. There's no such thing as a stupid question. Please ask if you need help. Please become a member of the AAVSO and donate. Everything that you've seen so far is being done using our resources and the very generous contribution of members and donors. We are a nonprofit. We're just trying to keep our lights on. So become a member, join us, be in our corner. And with that, I think I should stop. Thank you for your attention. Stop sharing my screen, just reveal myself, stop sharing my screen, and ask if there are any questions for me.
Thank
Stella.
you very, very much, Stella. And
Yes.
Steve, why don't you go ahead and, yes, we're all going to give you the clapping here. Yay.
Yes, thank you, Stella.
And then Steve, I think you saw the chat. I didn't. So if you have questions, Steve, take it away.
Yeah, there are a few questions. First of all, how did Betelgeuse get its name? Do you recall?
I have no idea.
It's an ancient name. It goes back thousands of years.
It's an ancient name, and I think it's an Arabic name, as most of the stars in the night sky.
I think so.
So Arabs, right?
And I seem to remember it means armpit of Orion, but I think that might not be the best translation, but just because of its location. Yeah.
That's an excellent question. And if you give me 3 minutes, I'll Google it and pretend I'm smart and pretend I know, but you know how to do that. So I'm going to just leave it for you.
Exactly. Yeah. Another question is, with respect to variable brightness, is that driven primarily by the movements of stars themselves, or dust, or combination of factors?
I just told you. It depends on the star though, right? Betelgeuse is in this particular phase of its life that has the phenomena that I described going on for it. Now, as I mentioned, the fact that we found this dust episode, that actually the bright blob coming from the inside gets out, condenses, forms this big dust thing, does not exclude the other phenomena. Okay.
Yeah. Yeah.
So the two are not mutually exclusive. So the responsible answer I can give you about Betelgeuse is we'll see in another 100 years, I guess. Keep observing. Seriously, keep observing. Who would have thought a star that has more than 100 years of data would actually come and surprise us? I went to the meeting of the American Astronomical Society, my last trip, in January of 2020. And we had actually a table there, and I had individuals, professional astronomers, coming to me and telling me, what's the deal with Betelgeuse? And I had this kind of impulse of apologizing to everybody and telling them that it's not my fault. As in, I have no idea. Just keep taking data and following the phenomena. It was right when it was going down, really down. We can see it.
I just Googled it and it says it's from a mistranslated Arabic name meaning, quote, the hand of Orion. And it's, I can't pronounce it anyway, that said it's mistranslated Arabic name. So there you go.
Mystery solved.
Cool.
There you go.
Yeah.
Okay, Stella, next question. Are there other stars that are on the cusp of going supernova? And if so, how would their
Yes.
brightness compare to that of a supernova Betelgeuse?
Okay, two different questions. The first one, are there other stars that will become supernova within the next hundreds of thousands of years, right? That's the timescale we're talking about here. The answer is yes. And actually, we have a project that we are working with a team that is working on detecting neutrinos from those stars. So when a supernova happens, you have like the implosion explosion of a star, right? Whatever is left can be a neutron star or a black hole, whatever. It's going to do its own thing. But then a lot of light is going to be ejected. During the first stages, what is actually escaping from the star first is neutrinos. Very high energy particles. They travel with the speed of light. So we will actually detect neutrinos first, and then we'll see the optical light. So this particular team, it's called SNEWS, S-News, is actually trying to capture the next bright supernova here on Earth through detecting neutrinos first, and then the optical light. Now, mind you, the time scales, neutrinos escape and travel. Light escapes and travels, follows neutrinos, right? Both with the speed of light is minutes. So they're going to get the neutrino detection, and somebody needs to get on target right now to actually see the visible light. So they're working on their alert system, and we have a collaboration so that the AAVSO observers will actually jump on the next bright supernova. Now, how bright it's going to be, I have no idea. Honestly, I don't know. It depends on which star we're talking about and what the mass of the star is right now. So I gave you a very long answer here. There are other very interesting stars like Betelgeuse. Very interesting, and they're bright.
Yeah.
Great.
Thank you, Stella. Next question. Even though our sun is in a different stage than Betelgeuse, what can we learn about our sun as a result of what's observed on this star?
See, Betelgeuse's initial mass was 10 to 20 times the mass of the sun. It was a little bit more massive than our sun. So what we can learn is more about stars of its mass. Okay, not much about our sun. Our sun is giving us a prototype to understand phenomena that we know happen in other stars as well, like convection, for example. Mm-hmm. Convection is something that we can understand, we can observe. I showed you a beautiful real movie from convective cells in the sun. But other than that, Betelgeuse is a different beast. Let me put it this way.
Okay, last question so far. Are there any planets present?
I love this question. I have no idea. No one else does. Betelgeuse is so bright that if there are any planets, let's see, there are no transiting planets that we know of. That's one. In this particular stage, if Betelgeuse had a planet when it was on the main sequence, before it lost its mass and became what it is right now, it might have engulfed them. So, for example, when our sun continues its growth and becomes an adult, becomes a red giant, its size will expand. It gets all the way maybe to Jupiter, actually. It's going to eat the Earth. It's going to, fry Mercury and Venus and threaten Mars, and it's going to go all the way out. Now, Betelgeuse is extremely massive. So in order to have, can you have a planet? You can't even have a planet that we call cause a noticeable wobble of the star itself. So if there are any planets, any remnants, we just have not detected them. I wouldn't be surprised there are some, like far away from the star itself, like in orbits similar to Pluto, for example, here for our solar system.
Right. Okay, another question came in. You described 2 different periods of change in brightness. Do we know what causes this?
We believe that these are cold spots, like dark spots, big areas of cooler material that emerges and goes down as a result of convection.
Right.
When you don't understand anything, blame convection and magnetic fields, and you're there. Oh, now add dust. Here you go.
You can explain anything, can't you?
Everything.
And any other questions?
I would like to leave a quick, well, first of all, welcome to anybody who has never been to one of our science taverns before. Welcome, welcome. And we do this every second Sunday of the month. And next month we have another astronomer, right, Steve?
Yes, yes. Robert Ney, who's past editor of Sky and Telescope, is going to talk about the mysterious signal received from Proxima Centauri. So another stellar mystery that we have to sort of continue to monitor.
Okay, great. And then in April, we're going to have another cave talk because this is the year of cave and karsts. So we'll have another cave talk in April, and then I don't know after that. So stay tuned if you're new, and just keep watching the meetup group. And are there any other questions before we give Stella another big round of applause? Okay, thank you, Stella. Yay,
Yes.
we appreciate this very much.
Thank you
Yes.
so much for keeping me
Okay.
company.